The solar system is our neighborhood, but it's far from ordinary. Beyond Earth, every world pushes the limits of what's possible. Boiling oceans of metal, skies of sulfur, ice harder than granite. None of these places could keep us alive for more than moments without heavy protection. But that's not why we're here. We're here because each one pushes the limits of what a planet or moon can be. Each stop on our journey was chosen for a reason, from searing heat to crushing pressure, from volcanoes taller than Everest to oceans sealed under ice. Together, they reveal the extreme range of environments our solar system can create. Today, we'll travel from the sun's blazing doorstep to the frozen edge of its light, exploring places so extreme they almost feel impossible. Our path begins at the closest planet to the sun, a world that should be nothing but fire, yet hides cold deep enough to trap ice for billions of years. The sun here isn't a distant disk. It's an overwhelming presence, hanging 3 times larger in the sky than it does from Earth. Its light is so intense, it washes the color from the landscape, turning craters and cliffs into blinding silver and shadow. In this glare, the ground bakes to about 430 degrees Celsius, 800 degrees Fahrenheit, hot enough to melt lead. But Mercury has no thick atmosphere to trap that heat. Step into darkness, and the warmth vanishes. Temperatures plunge to minus 180 degrees Celsius, minus 290 degrees Fahrenheit, in minutes. With no air to erode it, the surface has stayed much the same for billions of years. Ancient impact craters overlap in a chaotic record of the early solar system's violence. Vast scarps, cliffs hundreds of kilometers long, mark where Mercury's crust has buckled as the planet slowly shrank, cooling from the inside out. And then there's the paradox. Near its poles, some craters never see the sun. Radar scans have revealed bright reflections there, deposits of water ice, preserved in perpetual shadow for eons. Mercury isn't just a scorched rock. It's a world of extremes, swinging from furnace to freezer in the span of a single day. From here, our journey takes us to a planet where heat is inescapable, day or night, and the air itself could crush you. From a distance, Venus glows like a pale yellow star, almost Earth's twin in size and mass. But up close, the resemblance ends. Its atmosphere is a crushing ocean of carbon dioxide, more than 90 times thicker than ours. Standing here would feel like being nearly a kilometer under the sea, with pressure squeezing against you from every direction. And the heat? A steady 465 degrees Celsius, 869 degrees Fahrenheit, hot enough to melt zinc. And it never cools, not even at night. Thick clouds swirl overhead, laced with droplets of sulfuric acid. Sunlight barely penetrates this shroud, but what does get through is trapped, bouncing between the surface and clouds in a runaway greenhouse effect. That's why Venus is even hotter than Mercury, despite being almost twice as far from the sun. The ground is a landscape of volcanic plains and fractured highlands, mapped not by cameras but by radar from orbit, because visible light can't pierce the clouds. Some of those volcanoes may still be active, venting heat from the planet's restless interior. If Earth shows what a habitable world can be, Venus is its warning, a reminder that climate can shift from life-friendly to lethal on a planetary scale. From here, we turn away from the sun's inner fire and set course for a moon where the ground itself erupts into space. As we arrive at Jupiter, its gravity dominates the sky, a striped giant filling the horizon. But our destination isn't the planet itself. It's Io, one of its 4 large moons and the most volcanically active world in the solar system. The surface here is a riot of yellows, reds, and blacks. Sulfur and frozen lava painting alien patterns across endless plains. Most of Io is frozen under an airless sky, with average temperatures near minus 130 degrees Celsius. minus 202 degrees Fahrenheit. But when lava breaks through, it can reach over 1200 degrees Celsius, 2200 degrees Fahrenheit, hotter than any eruption on Earth. This contrast is the result of a unique power source. Jupiter's immense pull, along with the tugs from neighboring moons Europa and Ganymede, stretches Io's interior like clay, generating enough friction to melt rock into vast underground seas of magma. The result? Eruptions so powerful they hurl molten material hundreds of kilometers high. Fountains taller than Mount Everest. There's no air to carry sound, but the violence is visible everywhere. New lava flows cutting through old ones, mountains as tall as the Himalayas, pushed up by relentless tectonics. This constant resurfacing means Io has almost no impact craters. Every scar is erased by fresh eruptions. From this churning, restless world, we'll head farther into the cold, toward a moon where the surface is locked in ice, but an entire ocean may be hidden below. Leaving Io's fiery chaos behind, we arrive at a world that looks almost calm. Europa, another of Jupiter's large moons, is smaller than our own moon. Yet its smooth, bright surface makes it one of the most striking objects in the solar system. From orbit, it appears like a cracked pearl, a shell of ice etched with long, dark lines that stretch for thousands of kilometers. The temperature here never rises above minus 160 degrees Celsius, minus 260 degrees Fahrenheit. The ice is harder than rock, but beneath it lies something extraordinary, a global ocean kept liquid by the same tidal forces that power Io's volcanoes. This ocean may hold more water than all of Earth's seas combined, sealed away under 15 to 25 kilometers, 9 to 15 miles of ice. Those dark lines across the surface are fractures where the ice has shifted, pulling apart and refreezing as the ocean swells and contracts beneath. In some places, reddish material, possibly salts or organic compounds, stains the ice, hinting at chemistry that could feed life. We've never seen this ocean directly, but the evidence is mounting. Plumes of water vapor, likely erupting through cracks, have been detected shooting hundreds of kilometers into space. If Io is a world shaped by fire, Europa is one shaped by hidden water, and perhaps, just maybe, by life. But our next stop takes us even farther from warmth, to a moon where rivers and seas exist, not of water, but of liquid methane. Saturn's largest moon, Titan, greets us with a hazy orange glow. Its atmosphere is thick, denser than Earth's, and rich in nitrogen, with a cocktail of methane and other hydrocarbons drifting in the air. The pressure here is gentle compared to Venus, about 1.5 times that of Earth at sea level, so you wouldn't feel crushed. But the temperature is a different story, an unrelenting minus 179 degrees Celsius, minus 290 degrees Fahrenheit, cold enough to freeze water into bedrock. Despite the deep freeze, Titan has something no other world but Earth possesses: stable liquids on its surface. They aren't water. They're seas and rivers of liquid methane and ethane, fed by rain from methane clouds. Vast lakes like Kraken Mare and Ligeia Mare stretch for hundreds of kilometers, their surfaces rippling under an alien sky. Standing on Titan's shore, Saturn would loom far larger than our moon does from Earth, its rings casting pale shadows through the haze. Beneath the icy crust, scientists believe another ocean exists, this one of water mixed with ammonia, making Titan a world of double seas, one above, one below. Here, chemistry is working in slow motion, perhaps resembling the conditions on early Earth before life began. From Titan's alien lakes, we travel to a smaller, brighter moon, where the surface itself shoots geysers into space, revealing another hidden ocean. Far smaller than Titan, Enceladus is a frozen jewel only about 500 kilometers, 310 miles across, small enough to fit within the length of the British Isles. From a distance, its surface gleams white, reflecting nearly all the sunlight that touches it. The temperature here never rises above -200 degrees Celsius, -330 degrees Fahrenheit. Yet this tiny moon has become one of the most exciting destinations in the search for life. Along its south pole lies the Tiger Stripe terrain, a set of deep, parallel fractures where something remarkable happens. Plumes of water vapor and ice particles erupt from these cracks, blasting hundreds of kilometers into space. Cassini, the spacecraft that revealed Enceladus's secrets, even flew through these geysers, sampling their composition. The results showed salts, organic molecules, and hints of hydrothermal activity, signs that a salty ocean lies beneath the crust. Warmed by tidal forces from Saturn's pull, the icy grains from these plumes drift outward to feed Saturn's faint E-ring, meaning Enceladus is actively shaping the planet's environment. If an ocean exists here, shielded from the harshness of space and rich in the building blocks of life, it could be one of the most promising places for biology beyond Earth. From this brilliant white world, we'll travel to the outer frontier, a dwarf planet with a frozen heart and mountains of ice under a dim, distant sun. Once considered the ninth planet, Pluto now drifts in the Kuiper Belt, a frozen realm beyond Neptune where sunlight is a faint glow. Even at high noon, the sun looks like a bright star, and the surface temperature hovers near -230 degrees Celsius, -380 degrees Fahrenheit. Pluto's most striking feature is Sputnik Planitia, a vast heart-shaped plain of nitrogen ice. It's not static. The surface here slowly churns in giant convection cells, with blocks of ice the size of cities rising and sinking over millions of years. Around it rise mountains of water ice, some taller than the Rockies, hardened by the cold to be as rigid as granite. The thin atmosphere, made mostly of nitrogen with traces of methane, escapes into space in a slow, constant flow. Yet Pluto is not entirely lifeless in appearance. Its surface colors range from bright white to golden brown, shaped by complex organic compounds created when sunlight interacts with methane frost. When New Horizons flew past in 2015, it revealed a world far more dynamic than we imagined. One that, despite its small size and distance from the sun, still has geological activity. It's a reminder that even on the solar system's edge, worlds can surprise us. From this frozen frontier, we turn for home, carrying the stories of fire, ice, oceans, and skies unlike any on Earth. Our journey has taken us from the sun's burning doorstep to the frozen edge of its light. Worlds where heat melts metal, air can crush you, volcanoes rise into space, and oceans hide under ice. None could ever host us, yet each reveals what's possible in the cosmos and reminds us how rare Earth truly is. If you enjoyed exploring with scientific facts, subscribe for more journeys just beyond the horizon, and share this with someone who still thinks space is empty darkness.